paying attention. I know you are. So, before we start, let's write up here the most important thing, and that is if we have some base to an exponent equals some answer, we can transpose this. We can transpose it into log form, and we're going to write log of the base of my answer equals my exponent, okay? Okay, that's super important, and you can go both directions with this. Okay, it's just what's up on the board. Okay, same stuff that's on the board, okay? This is everything. This is how we use logarithms, okay? So, example 1, we're just going to write it from exponential to log. We're just going to change it. We're not going to solve it. We're not going to solve it. I just want you to transpose it. So I'm going to rewrite it like this. I'm going to go log base E of 10 equals x. Thank you. Who said that? Much better answer. ln of 10 equals x is the answer I'm really looking for. Good job. Was that Braden?
Yeah.
Nice job.
Nice job, Braden.
Okay. 2, we're just going to go and do the opposite. We're going to change it to exponential form. So I'm going to go 8 to the x equals 16. That's all you have to do. You don't have to solve it. Just rewrite it. Tell me if I get going too fast, please. I don't want to go too fast. Okay, number 3, I see 1, 2, 3 logs, right? I want to put it together as a single log, so I'm going to go log base 4 of. Well, where it says plus, I'm going to multiply, and where it says minus, I'm going to divide, so I'm going to go 16 times 10 divided by 20. And well, I don't know what that is. 16 times 10 is 160 divided by 20. Should be 40, right? Hold on. 16 times 10 divided by 20 is, 8, I guess. Okay, so it's really the same thing as log base 4 of 8. Okay, that's 16 times 10 divided by 20 is 8, okay?
Log base 4 of 8.
Yep, because all I did, Emily, was this. What is 16 times 10 divided by 20 is just 8. That's all I did, okay? Okay, now, graph this function and its inverse. So what I'm going to do is get a piece of graph paper out. Anybody need graph paper? Or do you have it? You probably have it in your notebooks. So I'm going to graph this. And we're going to be able to do this. We've done this graph lots of times. Okay, number 3, number 4. I'll wait for you. Okay, so this is kind of hard to do, but this one's pretty easy. These are opposite. This is the base 2 to the x. This is like 2 to the 1, 2 to the 2, 2 to the 3, right? 2 to the 4. We're going to graph this first. To get this, we'll be able to graph this. Okay, does that make sense? Okay. So let's just do this real quick. If I plugged in 0 to the 0 power is 1.
if I plugged in, actually I'll do it here. I'm running out of room. Y equals 2 to the x. If I plug in 0, I get 1. Anything 0 power, if I plug in 1, I get 2 because 2 to the 1 power. If I plug in 2, what's 2 to the 2 power is 4. Okay. If I plug in 3, 3 to the 2 to the 3rd power is 8. You guys okay with what I just did? Plugged in, and you can use your calculator if you want to. You can go 2 to the 0, okay, 2 to the 1, okay, 2 to the 2, and 2 to the 3rd, okay? So these are points, 0, 1, 1, 2, 2, 4, and 3, 8. Okay, so we're pretty sure it looks like this, right? It's an exponential, right? You guys remember that? That's like our Skittles. If we want to do the log, we're going to inverse. Well, to do the inverse, 1, 0. 2, 1.
Is this going to be the opposite?
Yes, totally right. So inverse in math, Kevin, means opposite. Good job. So we're just going to switch, right? Because we're looking for the inverse. And now graphing's easy, right? 1, 0. 2, 1. 4, 2. And 1, 2, 3, 4, 5, 6, 7, 8, 3. It looks like this. One more thing I'd like on there is the asymptotes. Remember about the asymptotes? I have an asymptote here, and I have an asymptote there. Okay? So draw the asymptotes in. Okay, that wasn't too bad, right? Okay? Victor, pay attention, please. Okay, that wasn't too bad, right? Can you do that tomorrow?
Maybe.
Okay. All right. All right. All right, now, the graph of g of x is a transformation of fx. So this is f of x, okay? I didn't give you the question. So let's do this. Let's make g of x be f of x plus 2. Okay, what does that mean? It means we're going to take this graph, we're just going to move it up 2. We're going to take this graph, we're going to move it up 2. So I'm going to take probably this point right here, looks like the easiest one to move up because of the plus 2. And I'm just going to re-sketch this graph just up 2. Did I read this wrong? fx log. Oh, you know what? It was.
Down 2.
It's actually upside down. You know what? Kestrel. Oh, I'm so glad you're here. So it is a normal log looks like this. Thanks, Kestrel. So it's just upside down, right? So it's going to be a g of x equals a negative log of x. Because it's this one just flipped upside down, isn't it? Thanks, Kestrel. All right, I made up 2 different problems. This is the one they really wanted. Do you see how it goes from here to here? This is the one I want. I'll have to help you tomorrow on this one, okay? I'll help you tomorrow on this one, okay? I will help you on that one. Okay, let's move on to number 6. Okay, or I might even just take 5 off, or I might even make 5 extra credit. Maybe I'll make 5 extra credit. I'll make it extra credit. How's that sound, Kestrel?
Yes.
Yeah.
Sounds good.
Okay, now what about 6? Solve for x. You can do this. What are you going to do? Tell me what we're going to do for 6.
Change it into a different form.
Yeah, log form, right? So we're going to go log base what? Of? Not of x. Okay, see if you can get the answer. Now, if it's regular log base 10, that's just the regular log, isn't it? You could also go in your calculator, use your log base, but I'm just going to go log of, because that's my invisible base, is my log base. How about 4.05? 4.055. Okay. I'm probably going to need to do some of these on a separate piece of paper pretty soon, but how about 7? What are we going to do?
LN,
ln is correct of
8, negative.
-8. Okay. You ready for this? Error.
Why? Negative.
It's negative, right? So we say no solution. And you know what, Emily? Even if you didn't see it, you can still do it because you're going to go like this. You're going to go ln of -8, right? And you're going to get that. See what happened? And you're going to, wait a minute, Mr. Davey said you can't take logs of negative numbers, right? So if you hadn't seen it, you'll see it once you push the buttons, right? Okay, number 8. And I'm going to do 8 on a separate sheet of paper so I have room. Okay, 8. All right, what do you think we should do? Let's change it to exponential form. Change it to that, exponential form. So we're going to write it as 3 to the 5 equals x. 3 to the 5th, is that 343? Hold on, 3, 2, is it 243? Sounds right, 243. Yeah, 243.
Equals X.
Yeah,
That's it?
that's it. Wasn't that easy? Okay, how about 9?
Multiply.
Divide. That's what you meant to say, right? We're going to divide by 6. Divide by 6, right? I have 3 to the x equals 12. Now what?
Divide.
Can't divide, but we can change it to
Oh, put it into
log, and then we can use a calculator, right? We can go log base 3 of 12 equals x, right? And then I'm just going to use my calculator. Okay, hopefully you have a good one. I do have a good one right here. Okay, math. Log base 3, 12. Okay, about 2.262. 2.262. If you don't round perfectly, I'm not going to mark it wrong, but I like to round to the nearest thousandths. But if you don't round correctly, I will not mark it wrong because you did the problem right, correct? Okay. All right, number 10. Slide down. Okay, number 10. So what I see in number 10 is I could probably make 125 into a 5. Can you see that?
Yep.
So 125 is 5 to the 3rd power. Okay, and then, since I got the same bases, right? Okay, so I just cancel out the bases because I've got 5 to this, 5 to that. Okay, then plus 9, 3x equals 12. I am so embarrassed. I had a kid in my algebra class who couldn't do this. I'm like, no. Ouch. Ouch. Right? Everybody agree? Thumbs up, you can do that tomorrow? Yes, I would. I'd love, yeah, no problem at all. Number 9. Okay, I divide by 6 first. And then I got this after I divide by 6. And then I changed it to a log form and used my calculator. Log base 3 of 12. Okay. All right, let's look at 11. So 11, I'm going to change it from a log form to exponential. Okay, log form to exponential. So we're going to go 4 to the 2 power equals a 4x minus 5. Okay. Well, 4 squared is 16. Okay. plus 5 plus 5. 21 equals 4x. Divide by 4, divide by 4. I think that's 5 and 1/4, or about 5.25, I think. If I use my calculator, I'm pretty sure it is. Do you have 5.25 also? Yeah, I think so. Good.
Can you just leave it as 21 over 4?
I would take that. Yeah, I would take that, Emily. Sure. Absolutely, I would take that. Yeah. I'd take 5 1/4. I'd take 5.25. I'd take any of those answers. Yeah. Okay, now, 12. Okay, what I see about 12 is this. It's ln, ln. So what's inside has to be equal, because ln of this equals ln of this. So really, since they're both ln of this, I can just cancel them out. Go straight to 2x plus 9 equals 5x minus 6. It makes sense, because they're almost identical except for what's inside, right? So to make them equal, set them equal. Okay, then I'm going to solve. Minus 2x minus 2x, 9 equals 3x minus 6, right? Plus 6 plus 6, 15 equals 3x. Yep, divide by 3, x is 5. Okay, can you do that tomorrow? Good. I know you guys can do this. Shouldn't be as hard as some of the other tests we've done. If you just can do this transposition between there, here, or there and there, you're good to go. Okay, 13. I'm missing a number. What's my invisible number? What's my invisible number? E. E. Make sure you put that E right there. Now, why is it E? Because it's ln, right? It's natural log. Okay, so 13. I'm going to go just simply E to the 0.8 equals x, because I changed it from log form to exponential form. Now, what is e to the 0.8? I don't know. That's what calculus is made for. I'm going to go e to the 0.8, and I got an answer of about 2.256, I guess. 2.226, if I round to the nearest thousandths.
What, that's 13?
That's number 13, yes. Okay, you ready for 14? Okay, 14, I'm going to go through it slowly. This is what we did on our warm-up. So here's the first thing. 2 points, 2 equations. It says exponential equation, so write this down. Y equals a b to the x. Write that down somewhere, okay? So I need 2 equations. I have 2 points. So I need to use my y equals ab to the x power. 3 goes for y, 1 goes in for x. Take good notes on this. You can do this. 3 goes in for y, and 1 goes in for x. So now we're going to solve for a. Solve for a. And to do that, I'll have to divide by b. So I have 3 over b equals a. Okay? Two equations. All right? Y equals ab to the x. Okay, 2 equations. I'm going to substitute this right there. Substitute. Okay. So I'll rewrite this as y equals not a, but 3 over b. I'll replace a with 3 over b. So I'll put 3 over b right there and for a. Okay. Well, I was given a second point for a reason. So my second point has an x and a y also, right? So I'll put my 24 in for y. and I'll put my 4 in for B. Now I need to simplify a little bit, which I will. One of these B's cancel one of these. I got a 24 equals 3B to the third power. Okay, I just simplified B for B. I need to solve for B. I'll divide by 3, divide by 3. 8 equals B to the third power. Cube root, right? I got to get B by itself, so cube root, right? It's got to be cube root. So I've got B equals, the cube root of 8 is 2. All right, now I still need to find out what A is. So I'm going to take my 2, put it right there to get my B, or my A. So I put my 2 in for B, and I have 3 over 2 equals A, or 1.5, or 1.5, but 3 over 2, right, Emily, is good enough, right? So let's see, what's my equation? So my equation's going to be, well, I got to use y equals AB to the x. I know what A is. A is 3/2. I know what B is. 2 to the x power. So there's my equation, right? Now, I think it asks one more thing, and I want to use my equation. It says f of 3. Well, I'm just going to use my calculator. So what is f of 3? That means to plug in 3, right? So f of 3, I'm going to put that in my calculator. I'm going to go, okay, what is f of 3? I'm going to go just simply 3/2 times 2 to the third power. Let my calculator do the work. I'm going to go 3/2 times 2 to the power of 3, and I get 12. How am I doing? Am I going slowly enough? Doing okay? All right. Getting ready to turn the page. All right. Last but not least. Okay. So, I got to make a scatter plot. All right, I can do that. I've got some graph paper around here. Let's make a scatter plot. And here's our trampoline again. So this is my years. This is my trampolines. So it seems like my trampolines get all the way to 96. I'm going to go by 10s, right? I got to go by 10s. Take a fit. I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. Here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, I don't even need 8. Okay, scatter plot. 1 to 12 is about there. 2 and 16 maybe there. 3 and 25 is maybe there. 4 and 36, let's see, 10, 20, 36 is maybe there. 5 and 50. 6 and 67. Let's see, 67 is right about there maybe. 7 and 97. Okay. All right, looks exponential to me. Definitely looks exponential to me. So, let's use our calculator, okay? So we're going to go to our calculator. Do you remember how we did this? Do you want me to write down the steps? I'll write down the steps. We go to Stat. We go to Edit. We're going to clear all our data. Clear. And then we're going to enter our data. Then we'll go back to Stat. And then we'll go to Calculate. And we're looking for exponential regression. Okay, those are the buttons I want to push. Okay. So while you're writing those down, I'll do it. I'll do it for you. Okay. So go to Stat, Edit, and get rid of all my old data. I'm going to put in my new data, enter data. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 12, 16, 25, 36, 50, 67, and 96. Okay? So then I go back to stat, to calculate, and the one I'm looking for is right there. Exponential regression. I push enter, go to calculate, and there's my answer. So my answer's got to be a y equals ab to the x. They tell me what a is, about an 8.457 times my b, which is a 1.419 to the x power. Okay, want me to slow down for a second? Okay. So I just used my calculator, got the answer. Okay, year 10, we're just going to plug 10 in for x. So I'm going to go ahead and write y equals 8.457, 1.419 to the 10th power. And we're going to go 8.457, 1.419 to the 10th power, right? Boom, there it is. About 280 trampolines. So it's about approximately 280 trampolines, okay? Then we want to know how many years to sell 500. So we need, now we've got 500 trampolines. So I'm going to take my equation and I'm going to put the y as 500, because that's trampolines, right? Equals my 8.457, 1.419 to the x. Okay, so I'll slow down for a second. Okay, now I need to solve for x. I know I'll have to do a logarithm eventually. Okay, I'm going to have to do a log, but first let's divide. Okay, we'll divide. So we're going to have to use a log eventually, but I'm going to divide by 8.457. 8.457, use my calculator, it's 500. Divided by 8.457, okay. I get a 59.122. Now my calculator can do any base, even that base. It can. It's a good calculator. So I'm going to go log of base 1.419 of 59.122, and I'll get how many years. Go to my button in my math. Log. I'll go base 1.419 of my 59.122, and I get an answer of about 11.65 years. Okay, now stop.